Hello, good evening. My name is Jayla Fairley, and I'm working with Brandon Ricks. Tonight we're going to go over our unit circle. So right here is a general picture of your unit circle. Basically, I'm going to go over how to do it and basically what it kind of stands for, what it means. When you look at a unit circle, it's splitting up into 4 different quadrants. Your first quadrant, second quadrant, third quadrant, and then your fourth quadrant. Here in your first quadrant, all of your trig functions are going to be positive. Your second quadrant, just sine and cosecant is going to be positive. Your third quadrant, tangent and cotangent is positive. And then your fourth quadrant, just cosine and secant's positive. Now to go a little bit more in depth in the middle, basically here is your basic line, basically your starting point. Your baseline, 0 degrees with no radians, and then here, your first quadrant is split up into 3 different parts. Your first line is 30 degrees, and basically this number right here is basically saying your radians. So 30 degrees converted to radians would be pi over 6, 45 degrees would be pi over 4, 60 degrees would be pi over 3, and 90 degrees, if it was drawn to scale, would be a perfect right angle, so it would be 90 degrees. Right here on the outsides are just basically your points, basically where it falls on the unit circle. And one thing to also keep in mind, a unit circle always has a radius of 1, so that's how we know that is a unit circle. Now, that covers just a basic idea of what your unit circle is and how to use it. Now at this point, Brandon's going to give me my 2 problems that I have to do, and we'll work them out.
The first problem is going to be sine negative pi over 6.
That look about right?
Yeah.
Great. So basically how to do this problem, you want to ignore the negative sign in front of it. Right now you just want to go and find pi over 6. So basically you want to go in here and look for your radians. You want to look for pi over 6. And you see that's right here in your first quadrant. And you want to give it, and you want to look for your points. And sine is always your y, and cosine is always your x. So sine of pi over 6 would be 1/2. But since it's negative, sine, cosecant, tangent, and cotangent is going to keep the negative, but the cosine and cosecant is not, cosine and secant is not going to keep your negative. So your answer would be negative 1/2. Now, I'm ready for the second problem.
Problem number 2 is cosecant of the inverse of 2 root 3 over 3.
Alright, does that look alright?
Yes, ma'am.
Alright, so basically this problem is asking for the inverse. So where on the unit circle will I be able to get 2 root 3 over 3? But unfortunately, the 2 root 3 over 3 does not fall properly on the unit circle. So that means that this problem was already rationalized. And rationalized just basically means that the radical is now in the numerator, because typically you don't want your radical in the denominator. So basically, to get that back original, you want to just put this radical back in the denominator where it was at originally. So generally speaking, you're looking for where on the unit circle would you be able to get 2 root 3? 2 root 3. So, and since I know cosecant's partner is sine, I'm going to look for it through the y's. Now, basically, if we look up here, if we flip it around, since cosine would be the opposite of this, it would be root 3 would be in the numerator, 2 would be in the denominator now. So if we find that, we can look up here, and that's where we'll see that answer at. So basically, your answer would now be root 3 over there. Your answer would be pi over 3 because you want to write your answer in radians. And yeah, so that's basically your solution to what is the inverse of 2 root 3 over 3. And now at this point, Brandon's going to go over his part and his 2 problems that he has to do.
Good evening, my name is Brandon Ricks, and I'm going to do my first 2 problems. What's the first one?
Alright, so the first problem is the cosine inverse of negative root 3 over 2.
Okay, from off the back, I see that we have cosine negative root 3 over 2. So I would go to negative root 3 over 2. And cosine is always x. So I will look at the x variable, and that gives me my answer right there. 5 pi over 6, which is the radians for negative root 3 over 2 cosine. So my answer is 5 pi over 6. That's my answer right here. 5 pi over 6.
Okay, and then your second problem is secant of negative pi over 6.
Alright, so I would go to pi over 6 on the unit circle, and I see that's right here. And secant is the inverse of cosine, and cosine is the x variable, which is the first one. And since secant is the inverse, you have to flip it. So I would flip root 3 over 2 into 2 over root 3. 3 over 2 now equals 2 over root 3. Now we could leave it like that, but the problem is we have a radical in the denominator, and you want to rationalize that. You don't want no radical in the denominator. You want to put that in the numerator. So we're going to change this right here into 2 times root 3. Then we got 2 over 3 root 3. Now this is the simplified version of the answer. Going from root 3 over 2. I'm sorry, 2 root 3 now to 2 root 3 over 3. And that's the final, that's everything. We just went over everything, the whole unit circle and the problems. I hope you learned something from our lesson. Thank you.